Yeah.
Hi, Stevie.
Hi, Peter. How are you?
Very well, thank you. Oh. Hi, Daniel. You're muted.
Hello.
Hi. And hello, Susan.
Hi there from Canada,
Ah, very welcome.
LaSalle, Ontario specifically, but
Oh, we've got Tim Long as well. Hi, Tim. We got you for a second there, Tim, but you're on mute still. There we go. Lovely.
There we are.
Hi, Tim. Recognize the voice now.
Yes, I can
Good.
recognize your voice.
There was a dialogue box that came up, something about recording, and it hid itself behind other windows.
Ah,
Right, yes.
well, it is being recorded, so
Yeah, that's all good.
yes.
Get some chat going. This is one of those times when having two screens is quite useful.
Oh boy, you're telling me. Now I just need to tip my glasses down so you don't end up seeing nothing but screens in my lenses.
You end up looking like Hypnotoad.
From your calendar, ASCOM and Alpaca Core Team conference starts in 10 minutes.
There you go.
Yeah, that's should probably say it again in a second.
From your calendar,
For some reason, I get the same thing. I get 2 calendar alerts from her.
Hmm. Hopefully that
Alexa, say hello to Peter.
hi.
will- yes,
Now I'm
very
gonna
clever.
Now
Very
I'm going to
clever.
push the dead button on that thing over here. Hold on.
It's a good job I haven't got my speakers on.
Yes. I presume that. Oh yes, big
there's
big healthy looking red light has just come on. So yes. Yes.
I was talking with my daughter today about a Kentucky Fried Chicken announcement or ad here in the US where it said, "Hey Alexa, blah blah blah," and it actually was ordering stuff, and a parrot that was ordering things for delivery at the house because he heard the owners do it.
Yes, I saw that on the YouTube. That was very amusing.
I got a package just now, but I got in just as after the announcement of my delivery.
Mm-hmm.
I got one of these things to read with which to read, and so far I kind of like it. That's hard not to. It's a Kindle reader.
Oh, Kindle, yes, absolutely. Yes,
Tiny
very
little
good.
thin thing, and it has a paper white.
Yeah.
It's actually really nice. It's nicer than reading, certainly than reading off the phone. and it's
Mm.
better than my iPad also. So
Yeah.
oh,
Brilliant.
now that's a really interesting icon there.
Yes.
Sheesh.
Yes. The precious toilet roll.
I wonder where he's looking at this video from. And that's actually a very good use for this.
I'm guessing, yeah.
We're getting them.
Absolutely.
Yes.
I should mute myself just in case something happens in here. Those of you who are, oh, they're not going to be able to hear me. I was going to tell them how to connect to audio, but there's a thing that pops up and asks if you're going to use the phone or the computer, and you have to answer that. So that's where they are, where it says connecting to audio. Looks like everybody but Andy. And I sent him a person-to-person note on that. So maybe he'll be able to connect.
Can you hear me, Bob? Oh, I can't hear you. No.
For a very good reason. I was muted.
Oh.
I can hear you.
Now
Okay.
I just unmuted myself. I just muted myself as a matter of course here. So I'll use my space bar push to talk.
Oh. We finally.
Howard, I muted you. Probably everybody here should be muted coming in. So
Robert, that's a very good microphone you have there. It sounds really good, much clearer than ones I have to use at work.
You're on mute, Bob.
plus I have some processing in the chain. I have probably not that many people would have a mixer like this that so I have this thing too. So it's all part of the package, and behind here is an audio processing plug-in and some other stuff. So
Very fancy. I've just got a volume knob.
this thing is really wide. I'd like to be able to adjust the zoom on this, but this camera, you have to buy their gaming software, and it's a huge package, and I don't know. So I'm just living with it.
Good morning, everyone from Australia.
Oh,
Hi, very welcome you are.
hey, there's Dick Post. Hi, Dick. You're muted, but everybody's muted when they come in. So if you want to talk,
I
almost,
just
there we go.
somebody else is on the moon. I see. We have Australia and the moon.
Andy got in. That's good. Wow, there's a lot of people I recognize here. Han, he's one of our Alpaca heroes.
Good evening, Han here. Is morning in your location, Bob?
Just afternoon. It's 1 in the after, 1300, 1 in the afternoon.
Okay, here's yeah, around 9, so in the evening, but fine.
We tried to pick a time that wouldn't be inconvenient, but that's hard to do for Australia.
How many did you have signed up?
We had it filled up to 100
Oh,
within 18 hours of the posting, and then I went out and bought an extension because several people from industry wanted to get in, and it was already full. So, and there are people I wanted in, people from simulation curriculum, the people. Oh, that's something else I've got to stop. Hold on, I forgot I had that. How's that? Oh, there it is. Hold on. I got to get rid of this bleeping email program. Ooh, somebody else just signed up. That's amazing. Ah, okay. Well, they're going to get in too. So anyway, I bought the 500 extension, and then I just put it out there. I didn't limit it, and so, but I didn't tell anybody that I'd done that. So the people I wanted to get in got in, and then other people have been dropping in through the week also. And Roz Hardigan from Simulation Curriculum just registered, and so she should be in. She's one of the authors. Actually, she's the developer for Sky Safari, the main developer for Sky Safari. I don't know, you probably know what that is. And so she should be here shortly. And although it's 1 o'clock, I think we'll wait just a little longer and maybe give it 5 minutes of buffer time here, and then we can go from there. And Stevie Denny, by the way, that you see with the striped shirt, that's
Hi.
her. That's my my boss, the
Yeah, right.
the chief operating officer of our company, and she's my boss. Well, we're each other's boss. Well, I'll say co-owners. There you go. And she's going to kind of moderate things and watch what's going on, make sure the recording is happening, which it is, and help out where possible. Somebody's not muted and has a lot of wind in the background.
That's Ross Hardigan.
Roz, okay. Oh, there you go. That's Roz, or Rosalind is her name. So we'll get her. And thank you for joining, Rosalind. I saw the registration pop in because I forgot and had my email running and it was dinging. So, all right, we're already up to one screen. And Stevie, you should see the arrows now to go to the second batch of people. Wow. Yeah, no kidding.
Yeah, I don't see where are the arrows?
On the very left and very right hand side of your main grid view.
Oh, I see. Yeah.
In the middle.
Okay. Yep.
It should say 1 of 2 and 2 of 2.
Yes.
So we're
all right.
Again, it's 49 is what one screen is. And when I shift It doesn't look like there are that many more. How many are there? 50.
50.
Okay, so
Mhm.
we're doing okay. We'll let it roll for another, I'll say 5 minutes, and then we'll get going. Manning said he wasn't going to make it. It's a good thing I didn't kick you off, huh, Manning? I see you're here. He said he was traveling and could I give and ask if I could give his slot up to somebody else. But since we had extra slots, I just left him in, and guess what? Here he is. Couple more minutes. Yeah, this is a good group. So we have some hellos from Prescott Mac Users Group. That's John Carter. Hello from LaSalle. Susan Sawyer-Beaulieu in Ontario, Canada. Hello from Netherlands, Chris Albert and Paul Smith from light polluted Tampa Bay. Well, you can probably all see this too. By the way, pop down at the bottom or wherever, look for your chat window and open that up. And you'll see what I'm looking at. I didn't need to read all this out. And note that you can send to everyone or an individual private message to somebody else if you want to say something. And it's now almost time. I'm just going to let it roll up to 105 and then I'll kind of open things up and play my video and introduce people, and then we'll go from there. All right, we are up to 52 now. That's good. Whoever sneezed, you're not on mute. And we'll mute everybody in a minute.
That's Fern. She's not even in the meeting.
That's funny. How did I do that before, Stevie? Mute all. Okay. All right. And that's it. We're almost there. I'd be careful not to push that leave button for me. All right. I guess we'll kick this off. Good morning or good afternoon and good evening to everybody. Thanks for coming. There are 52 of us in here now. This is great. We never thought we'd get anything like this for participation, and it's really gratifying to see all the folks here. Thank you. I should introduce the core group guys with which I work and where we're putting this on. And that would be Peter Simpson, who, Peter, if you can unmute and introduce yourself briefly, and then I'll tell people what you do. Oh, one more click. Do I need to ask you?
There we go.
There
No,
it is.
that's
Okay.
fine. I'm there.
There we
I'm
go.
done.
Okay.
Yeah, I should say. Good morning, afternoon, and evening, everybody. I'm Peter Simpson and one of the ASCOM Core Group, and have been associated with ASCOM for quite a while. So very pleased to be here on our first webinar.
And Peter is the person who's primarily responsible for the Azcom platform, and also it was his original idea of Azcom remote, that is to be able to remote the device on one Windows machine from another Windows machine through COM and then through a REST protocol. And as soon as he did that, then it was obvious that this was the way forward for Alpaca. So we have Peter to thank for the original concept of Alpaca and a lot of the implementation. And so he's really one of our very biggest developers. Well, both the two guys I'm going to introduce are really work hard on this stuff. Secondly, Daniel Van Noord is another core group member aside from me. And Daniel, go ahead and introduce yourself and let people know where you are and what you do.
Hi, everybody. As Bob said, I am Daniel Van Noord. I guess I'm from Michigan, and I work a lot on the cross-platform technologies for ASCOM and Alpaca, and specifically the Omni-Sim is what I'll be talking about today.
And I should mention that Peter has also ported the Conform tool over to be cross-platform, Conform U. We'll see that in a little while because both of those things, the Omni-Sim and Conform U, are coming up in videos. Quick announcement, and that is we're here to tell you about Azcom and Alpaca, how they came into being, what's going on, where it's going, and then also to show you two tools that are out there right now and to kind of fill you in on what you may think you're lacking in terms of information about that. Why, where, when, and how. So that's our purpose today, and we hope you'll enjoy it. So what we're going to do is even though the message we sent out said we're going to play the 3 videos back to back, we had a little pre-meeting and decided we're not going to do that. We'll play a video, short, like 6-7 minute video. Then we're going to open up for questions and answers on that one. Then we're going to play another video, open it up for question and answer for a short period of time, 8-10 minutes, something like that. And then after the third video, we'll open it up for question and answer for as long as you guys want. And so it's wide open after that. So with that said, I shall start with my video and we'll see you in 8-ish minutes. Just a moment. Welcome to the Azcom and Alpaca teleconference. Today we're going to cover 2 main topics: Daniel Van Noord's Omni-Simulator, which is an Alpaca cross-platform package of simulators, and also Peter Simpson's Conform tool, which is now cross-platform and native Alpaca. Before we do that, however, I'm going to go through a few basics, lay some groundwork. It won't take very long, and then after that, we'll move on to Daniel first for the Omni-Simulator. By the way, thanks to Matt Dietrich for that wonderful Nightscape time-lapse. First thing we're going to go through is really why Azcom and Alpaca exist in the first place. It won't take long. You guys are all developers, so I'm not going to belabor all of this. But as you know, without a common universal interface, you have to write adapter code for every single type of device out there. So if you were doing this, you'd have your own code to talk to mount A, B, C, and D. In other words, how many of these mount adapters must I write and support? Here's an example. This is Sky Safari 7, and we'll go in to connect up a mount the old way, and look at this list of mounts. These people had to develop code for every one of these mounts. So prospective app developers look at this and they see it as a big barrier to them getting into the business. But it's worse. Suppose a new mount comes out. Now the app developers are faced with writing code and testing with a new mount. Do they put that mount in their warehouse of all the other mounts that they have so they can test with it in the future? Do they borrow one? How do they get this thing? Once they have the support there, they have to roll out a new version of their app. It's a tough row. From the mount maker's point of view, as soon as you have a new mount, you have a choice. You can either try to emulate somebody else's gobbledygook along the serial line, or you have to go back to the app developers and beg them to support your new mount with your new protocol. All this adds up to problems for both the app and the mount developers, but here's the thing most people forget. When you have pieces of code in the app and pieces in the device, who's responsible for a problem when somebody has a problem? Trying to figure out whether it's the app's code or the mount or whatever device's code is a real problem. So you end up with a situation like this, and eventually you end up with a situation sort of like this. What we're here to do is put everyone on a common universal standard. An app need only write mount code once. A mount maker need only write a driver, and it's automatically compatible with all the apps out there. And when you're trying to solve a problem, where is it, in the app or the driver? By having a universal standard, it makes it easy to find out whether it's in the app or in the driver. Okay, let's switch gears and look at a little bit of layering and architecture. Before I go farther, I want to say that this is being presented in an evolutionary way, starting with the original classic Azcom and working our way towards the future. By its nature, this stuff starts with Windows-centric things. That does not mean that Alpaca depends on Windows. It does not. This is what we know of as Azcom has been for the last 20 plus years. Windows apps talk to a Windows driver, and the two communicate with COM. That's what we would call classic Azcom or Azcom COM. And then the driver talks over something like USB or Ethernet, serial, or whatever to the actual device hardware. Now, with the introduction of Alpaca, we have the possibility of an unmodified Windows COM application being able to reach out to an Alpaca device by having these new chooser dynamic drivers. Let me show you what that looks like. When the Windows app decides to display the chooser, it comes up and looks up for Alpaca devices anywhere on the net. If it finds one, there it is. You simply choose that, click OK to have it create the new driver for you. Mind you, this is a COM driver that gives access to the Alpaca device. It makes that permanent on the device. Boom, there it is, Alpaca Telescope Simulator. You'll hear more of that in our next presentation. At this point, an unmodified Windows app that speaks COM-flavored Azcom can talk to an Alpaca device out on the network with no changes to the Windows app at all. Now let's look at the flip side of this. Let's say we have an application out on Linux or Mac OS or iOS, as you'll see in a minute, that wants to speak to a mount that is running on a driver, on a COM driver on a Windows system, and there's lots of them out there, EQ mod, plane wave, whatever. Well, we also provide an inbound route from Alpaca back into Windows through Azcom Remote. Let's take a look at what that might look like from Sky Safari on the iOS, and we'll have it talk to the Azcom COM platform telescope simulator. In Sky Safari, you would just select the settings and go in and add a new preset. And this time it's Alpaca, and we discover. So Sky Safari found the telescope simulator, the COM one, on the Windows system, and we've go ahead and save that. Go back to Sky Safari, use that preset, and the next thing we know, boom, we can connect. And that is, there we are. That's now talking to a mount that is being controlled on a Windows system. In this case, it's the simulator that is part of the Azcom platform. I didn't want to use a specific mount. We don't, we try to keep this neutral as far as vendors are concerned. But again, because the simulator acts exactly the same as any other Azcom mount, it doesn't really matter. Okay, let's look at one more Windows involved possibility here, and that would be a Windows app that speaks Alpaca natively, and then an Alpaca driver running on the Windows system. This is the same layering as the original COM one that we looked at first, only instead of using COM for the communication, it uses Alpaca. Here we see the same thing with a Linux app running on a Linux machine with a Linux driver, an Alpaca driver, using Alpaca to speak between the app and the driver. This is the same, Windows or Linux, and we can do that on Mac. Because Alpaca is cross-platform, it is a universal truly now, even across operating systems. Now let's look at one more possibility, and that is the app on Linux, Mac, or Windows, which speaks Alpaca, the same app that would be in the last three slides, now can speak out over the network to a self-contained device. And that's really where we see the future in the long term. And that is devices that are out there on Ethernet or Wi-Fi, and no more USB, no more private protocol that you saw over USB or Wi-Fi, serial line, blah, blah, whatever that stuff was. That's all in the orange box at the bottom, and how that happens is not for us to worry about. All we need to do is speak to the Alpaca REST internet endpoints out there that have that common interface, and that's all we need to run the device. Okay, wrapping up here, I hope this diagram will help you imagine the possibilities with Azcom and Alpaca. And we're here today to help you try to understand this and ask questions and clarify the things that I didn't clarify in this video. Okay, thanks for listening to all that. I hope that helped you understand the overall landscape of Azcom and Alpaca. Next up, we'll hear from Daniel Van Noord, and he'll describe the cross-platform Alpaca simulator package, followed by Peter Simpson, who will describe the new cross-platform Alpaca Conform unit testing tool. Thanks for listening, and see you around.
You're muted, Bob.
Okay, how about this? That's better. We're not, thank you, Tim, appreciate that. We'll make other mistakes, I'm sure, as we go along. Anyway, we're not going to go directly into the next video with Daniel. We decided up front at our pre-meeting that we're going to give time for question and answer. So, let's see, I just got a beep here. Okay, good. And pardon me if I look, I've got multiple windows going here. I've got the chat thing going, and also we have a back channel on Discord between us three in case we have something to do that needs to be taken care of. So there's a lot going on here. We're going to do the best we can with this. It's a big meeting, but so far so good. Anyway, so instead of going straight to Daniel's video, we thought we'd open this up for question and answer for a bit on the video that you just saw and other concepts like that. And so if you have a question, put it into the chat of the for the meeting, and you can find that chat icon at the bottom of a Windows thing, or I think in the Mac, maybe there's a bubble icon. On mobile devices, it may be a triple dot or a hamburger menu or something, but there's a way to get on the everybody chat. And if you have a chat or a question, you can type it into there, or if you find that if we don't get people or they find it's difficult to do, you can also raise your hand, and you can find that under reactions. I'm going to raise my hand right now, and we'll see that, and it will also put you up here at the beginning, and then we'll bring you in that way. So if you have questions about what I just talked about, whoops, what did I do? I doubled up on my reactions. Just a sec, lower hand. Okay, that other thing will go away in a minute. Okay, anybody have any questions on what I just went over? Excuse me.
Bob, I see Phyllis Lang has a question. Do we have a native Alpaca package for Android? If so, where can she get it?
I will answer that. I'm looking for Phyllis. Did she raise her hand or did she put it into the chat? Oh, I see.
It's in the
there
chat.
It is. I see. Okay, I didn't have it scrolled all the way down. We don't have any Alpaca packages at all public right now. There are packages that are embedded in the two tools that you'll see, and there's Alpaca code embedded into the Windows side, but the libraries, because outside of Windows, well, let me back up. On Windows, we have a great situation because COM is language independent. It's available from 20 different languages except C++, but 20 other high-level languages on Windows can speak to a COM device in its native tongue, so to speak, or native syntax. But outside of Windows on other platforms, you have nothing like that. All you can do is work inside your specific language, and you can use the libraries that are out there for REST and for HTTP and all of that. But you pretty much have to put all this together for every language. So if somebody were to volunteer to put together an Android package, that would be great. And we would need that. We probably are going to need one for, well, we will need one for Python, that's for sure, because the stuff that what we're doing, the core group is doing the work that we're doing will be for C#, which is also cross-platform. Not a lot of people know that, but you'll see the tools that you see coming up are all written in C# and developed for, will run on all these different platforms. So it would be ridiculous workload for us to have to do the same thing in a bunch of other different languages, but someone has to do it for every language, because what this is, while it's cross-platform in terms of being an internet protocol, it's not cross-language. So every language is going to need a library. So if somebody wants to volunteer to do an Android one, or a Python one, or a Mac OS one, another language, that being the key. If they want one for Python, or they want one for, I guess, Android, would that be what, C++? Phyllis, do you, I'm looking for you.
That is what I do. Yeah. So I really, I'm writing in Embarcadero C++.
Oh, I see you now.
And it's currently running on Windows. And I would like to add it to my Android and iOS products. So I think, if I'm understanding correctly, I would write an implementation to the REST API. Yeah.
Yep. That would be right.
I can do that with cross-platform C++ tools, but the binary is going to be specific to the Embarcadero C++, I think.
Which is typical, because this isn't cross-language. You're going to end up, I mean, you can even run into stack, the stack ordering issues. There's all kinds of things at C++. It's so bare down on the bowels of, well, low-level programming. It didn't used to be, but it is. I mean, you have that. So, right.
Okay. So REST API documentation would be what I would need to develop in my C++ world for Windows or Android or iOS.
Well, there's a document that describes the Alpaca protocol, if that's what you're looking for. And that was on the, let me share, I'm going to unspotlight you, then I'm going to share my screen and go for basic screen one, where I got to move this thing out of the way.
I just posted the link to the API in the chat as well.
Okay, that's good. The document.
Yeah.
What I was going to do is show. There it is. That's what I want to post right there. Let's see if this goes right. Do you see the picture of a web browser? And if I move this out of the way.
Yes.
Okay, yes. So this is the Azcom website, azcom-standards.org, and published documents takes you there. And then down here to Alpaca, there is Alpaca API reference PDF, and there's that. And that should, oops, that came up as a separate, I can't. Right. But anyway, that's where to go and how to get there. And now I need to go back to my gallery view. Okay, I'm back, right?
Yes.
Okay, good. All right. And for everybody else, that website is where everything is. And thank you, Daniel.
I'll also add to that, if you are developing a client application, the Omni-Simulator video should be very helpful in that, because that's one of the things that's meant to do, is to help the development of clients.
And if you have a Raspberry Pi hanging around, I put together an Alpaca Workbench, which really literally takes almost no time to install, 10 minutes, and you've got the Omni-Simulator, the Conform, and also it shows you how to put Wireshark on there and get it to run, not root. So you can use it to look at the packets and trace through, and it makes it real easy to follow through the rest and the sequence of calling for Alpaca. So that's out there too. And it's on that same website under Alpaca Developer over on the right. And I'll go back and show people that later. There's another, did that pretty much hopefully answered yours, Phyllis?
Yes, it did.
Peter answered one for Dick Post, but I think it wouldn't hurt to answer. Is there any reason to switch to Alpaca if one is on a Windows machine using Azcom? No, the answer is no. Why? I mean, but if everything's working, it doesn't really. Peter's, oh, you can see this. Never mind. I keep forgetting this. The chat is for everybody to see. So you can read that. It's right up, it's a third or so note up, and that's a good answer. Thanks, Peter. James Bunnell mentioned curl libraries can help. And that's right. That's another way to interact with REST endpoints with curl. Okay, I think we may have run out of questions. So let's take it away, Daniel.
Hello everyone, my name is Daniel Van Noord, and I am part of the ASCOM Core Team. Recently I've been working on cross-platform Alpaca projects, primarily the Omni-Simulator. The Omni-Simulator is a project that exposes every single Alpaca device type as a simulator. It exposes them through the standard Alpaca APIs, and the program runs cross-platform. Currently it's capable of running on Windows, Linux, and Mac OS, and it can even run on a Raspberry Pi. These simulators expose many device configuration settings, allowing them to simulate and change their behavior to match the different options in the Azcom APIs. The project attempts to behave as correctly as possible in regards to both simulation behavior and the API structure and responses. Next, I'm going to demonstrate the Azcom Alpaca Omni-Simulator running on a Raspberry Pi 4. This Raspberry Pi 4 is running the stock operating system. The only changes I made was update all of the packages to the latest version and put the Omni-Simulator on the desktop. So I'm just going to start up the Omni-Simulator so we can take a look at the UI. The UI for the Omni-Simulator will run in the web browser for every platform. So on the Raspberry Pi, that is in the Chromium browser. On the left, we have a menu bar that allows us to access each of our different devices, as well as the server settings. The server and driver settings apply to things that apply to all devices. This is Alpaca configuration and security settings mostly. First device I'm going to show is a simulated cover calibrator, where I can connect to the hardware. This UI acts kind of like a normal Azcom client would. And I can actually take the brightness and set it to a different value. You can see it is simulating the level of brightness. If I need to go in and change one of the configurations of the device for testing an application, I can open up the setup, and I'm going to change the maximum brightness to 100. After I'm done with all of my changes, I can just save. And if I go back to the cover calibrator, I can connect and adjust the brightness, and now we can see that the maximum value we can reach is 100. Other devices, for example the focuser, offer additional settings where you can toggle on and off capabilities that are optional within Azcom, and also change some simulation settings, in this case how it simulates the temperature. The simulator also offers the ability to query an open API/Swagger document to view and to use each of the different Alpaca APIs that this exposes. All of them expose documentation that is identical to the documentation found on the ASCOM website, although please note that the documentation on the ASCOM website is the canonical documentation. For example, if I go down to the cover calibrator, I can set the state to connected by going in and selecting try it out. We only have one device, so it'll be device 0. I'm going to set the connected state to true and set the client ID and the client transaction ID to 1s and execute. We can now see the JSON response from the device indicating a success as there's no error message. If I then go over to the maximum brightness option, I can do nearly the exact same thing I just did, except I'm going to make the client transaction ID 2. And when I execute, we should see the value of 100 that we had just set in the settings. And you can see the JSON response, which includes a value of 100. Next, I'm going to demonstrate accessing this Alpaca driver from an existing Windows 10 system running the ASCOM platform. I'm going to use the ASCOM conformance tester to do this, which is a program for testing drivers. I'm going to be checking a cover calibrator, and I want to go in and I want to select my driver. Because this is an Alpaca driver, I go to the Alpaca menu and I enable discovery. So we can now see there is a new Alpaca device found, which is the device that I have configured on the Raspberry Pi. And I'll just say OK. The ASCOM platform is going to create a dynamic driver that anyone can use. And then if I go into the Properties menu, I can use this tool here to configure any sort of security or other connection settings that I need. Or I can access the web configuration, just like we did on the Raspberry Pi, to go in and make changes. Now this driver can be used just like any other normal ASCOM driver. I'm just going to run a quick conformance test, and we will see what results we get. So now Conform is exercising each of the different endpoints that the Alpaca driver offers, and we'll test to make sure that the simulation is running in a way that it matches the ASCOM specifications. And the good news is my simulator just passed the test. For my final demonstration, I'm going to interface the Alpaca Omni-Simulator with a Python script that is running on this Ubuntu machine. You can see I've got it running actually on the local machines. The driver is running natively on Linux. And I've opened up the web UI to the focuser page, but we're not actually going to change anything from the web UI. Instead, all of the requests we're going to do are going to come in from a Python script via the Alpaca API. And the script is very basic. It doesn't do any of the parsing of the responses or error checking that would normally be done, but it is sufficient for demonstration. In this case, it imports the Python requests library, which is a very simple library to use for accessing HTTP resources. The first thing we're going to do is we're going to get whether or not the focuser is connected and print that out. Because we're not connected currently, that should come back as false. Then we're going to put the connected state to be true. So we're going to set connected to true. We're going to read back the connected state again to see if it is connected. At this point, it should be true. We're going to get reading the position. Then we're going to put and tell the focuser to move to 6000. So let's give this a try. I'm just going to run the script. You can see our focuser has connected and it has started to move. If we look at our responses, we get the raw JSON response. We read back from our first request if it was connected that it's false. It is not connected. We then put or set the connected value to true, and because we didn't get an error number or an error message, we know that it succeeded. When we read back the connected value, we found out that it is now connected, it's true. When we read the position, we found out that the focuser was at position 25,000 to start. And then we started our move, which was running asynchronously as it was going, which we can now see is complete. So that's actually how easy it can be to interface and operate an Alpaca device from a Python script on Linux. And that was the last of the demos of the Alpaca Omni-Simulator for today. Thank you so much for joining me as we took a look at the Alpaca Omni-Simulator and the devices it can simulate, how to interface it or any other Alpaca driver with the Azcom platform, and took a look at some basic Python scripting for accessing Alpaca devices. We still have another talk for today, but hopefully I'll see you all again in the question and answer section at the end. Thank you very much.
Okay, thank you, Daniel. I did get one question from Tom Field. I punted on that until later because it's a long answer. It has to do with conceptual design of Azcom itself, and I'd rather not get into answering that right now, but I will be happy to after Peter's video. But there must be if there are other questions right now for the Omni simulator, fire away. And if either raise your hand or type something in the chat. I will say if somebody's typing something, I'll say this. I put the Omni simulator on a Raspberry Pi, and then you probably know I have a commercial software package that connects to just about everything. And I connected the whole thing up to the Raspberry Pi, the devices on the Pi, and ran, a huge 10,000 image multi-day run. And it worked like a champ. And it was all through the dynamic drivers, which was Peter's idea. And implementation, which is beautiful, because once you create a dynamic driver, like Daniel showed, it's permanent. Now that device out on Alpaca looks just like any of the other devices on Windows, except it's not on Windows, it's out on the net. But any program on the Windows system now will find that in the chooser and then be able to connect to it. This is also true once it's created of devices that show up in programs like SGP and Nina that don't use the chooser. So you don't have the ability to create the dynamic drivers in those programs because they mix everything together. They mix indie, com, native, everything gets in one list. So, and they don't use the chooser. They go and look in the registry and pull stuff out of there, which is not exactly supported, but it looks good. So, but they will show up there and they will be usable from those programs once created. So it's a pretty cool thing that Peter did on those dynamic drivers.
I see that Oliver has asked if the Omni simulator will run on a Raspberry Pi 3 or does it require a 4? The Omni simulator will run on Raspberry Pi 2, 3, or 4 without any problems. And the packages I'm delivering right now will run on Windows, Linux for both desktop Linux as well as ARM and ARM64 based computers like the Raspberry Pi and Mac OS. So you can host and run it on pretty much whatever you want. If you try to run it on a Raspberry Pi 1, may not be a great time just because you got one little tiny core to try to run it. But I test it on a 2 and 3 all the time.
And I should mention that when Daniel brought up the Swagger interface, the interactive API tester, it took a long time to launch. Keep in mind, that's a huge bunch of JavaScript code and it's running on a Raspberry Pi, including the browser. So it came up pretty fast. I was impressed when I started it the first time. I thought, why is this taking so long? Oh, it's a Pi. That's why. And I was running it on a 3. So it'll definitely run on the 3. And I'll say something about the Alpaca Workbench later, which Oliver, yeah, you may be interested in. So, okay. Chris Alberts, Alpaca is defined on the best practice of Azcom standard is defined on the, the process for changing the interface to add new properties or methods to the interface. That's your question. If you look on the Azcom website, there is a section in there that talks about the standards process and how to, first you would request it on the Azcom developers list. It would be discussed. Somebody would have to, then it would be filtered through other people. There's also things that, and we'll get into this because Tom Field asked a question that is related to this. How do we pick the things that are in the interfaces? What is the criterion, of how we put new things in the interface? And that we'll get into later. I think it's a great question to ask, and it's something everybody should understand. But the process, the standards process, is on the website, and I should have had this up, but I'll give you a map to it. Actually, I'll just post the. I think I can find this quickly. Peter, do you know where there it is? The standards process. It's right here. I'll just put it in the chat rather than going through all the trouble. 1, 2, 3, boom. Oop, come on, paste. Oop, that didn't work. One more time. Oh, now that. One more time. Copy and paste. There we go. Okay, that's where. So Oliver. No, Chris. That's Chris Alberts. That's where you can go to find the process on how that's done. We have one from James Bunnell.
Yeah, I've answered in the chat, Bob.
Ah, all right.
I will add to that chat response, and that is Discovery is specifically designed to only work over the local network, but there is nothing that stops you from running a Alpaca device over multiple network segments. However, it is typically best practice if you do to ensure that your segments are secured and there's no way for someone else to get on your device.
Right. And that's another topic that we can probably cover afterwards. On this link here, oops, I sent that to Tom Field, not everybody. That's dumb. All right, so that right there gives a scope of application and why how the security stuff was originally designed and why we did it that way. And so that's something that that might be useful. Let me put one more link on there about the standards process, which I sent by accident to Tom Field, and that's right there. So those two should be useful. So I'm writing things down here. And so I'll try to remember. I'll go back and write them down after we start the next video. Any more questions? Did I miss anything? Let's see. It is, yeah. James Bunnell, we'll get onto that, the local versus wide area, but Daniel pretty much covered it. So, okay, if there's no more questions for the moment, take it away, Peter.
Okay, thank you very much, Bob. Right, I'm just going to kick off my video. Share the sound, put the video on. Come on, there we go. There we go. And we're away. Hi, I'm Peter Simpson, and I've had overall responsibility for Azcom platform releases for the last 10 years. Today, I'd like to talk to you about our exciting new Conform Universal application. The Azcom interfaces lie at the heart of what Azcom provides. These are technical contracts so that clients can be sure of what operations can be carried out, and devices can be sure about exactly what information and what operations they need to carry out. Clearly, to be effective, both clients and devices need to use this same single universal language. So as developers, how do we know when we've delivered on the contract? That's a question which we all have to answer at some point. Unit tests are great, all sorts of internal testing is good, but it's also helpful to have an external standard against which we can test the products that we create. This is where Conform came in. Conform is a comprehensive test application. It exercises every type of Azcom device. Every single interface feature is tested, including the happy and unhappy paths through the interface, and it is robust and designed to be used in a development environment where applications, for example, may be only partially functional. This is what Conform for Windows looked like. Has been this way for quite a long time. It's a Windows Forms-based application, but there's no way that, like this, it could be ported to make it run natively on Linux, macOS, or anything other than Windows. So what we've done is to introduce our Conform Universal application, which runs natively on macOS, Linux, ARM, and Windows. It is a Blazor server application, so it uses an executable running natively in the operating system and uses a browser to provide the user interface back to that application. Conform Universal has feature parity with the original Conform. It can test Windows COM devices as well as Alpaca devices. Clearly on Linux and ARM there are no COM devices, so that functionality is disabled on those platforms. But when running on Windows, it can test COM as well as Alpaca devices. It also has a built-in native Alpaca client that enables it to see the Alpaca transactions and check on whether the rules around JSON casing, for example, are being obeyed by devices. It also has an Alpaca discovery built in, so there's no need for choosers with this particular application. Now, I'm going to demonstrate Conform U later on in this presentation, and this is the very basic test network that I have set up. 2 Raspberry Pis, 1 Pi 4 64-bit running Conform U, and a second Pi 3B 32-bit running the Alpaca simulators that Daniel talked about earlier in this presentation. This is the Conform Universal user interface. As you can see at the moment, at the top of the screen, no particular device has been selected, so the first operation has to be to select a device using the tabs on the left-hand side. Conform Universal has automatically gone out and discovered Alpaca devices on the network and has found by default telescope devices, so it has found the Alpaca telescope simulator that is running on the Pi 3B. If we wish to change that, we just simply select a new device type and it will automatically rediscover. If we had been running on Windows rather than the Pi 4 that Conform U is running on at the moment, we would also see a COM tab on here, and this would allow us to select COM-based drivers and to test those as opposed to native Alpaca devices. So at this point we will have selected a device and would be able to test it using the button on the home screen. For anyone who is, has got familiarity with the Windows version of Conform, you'll find the settings on here very familiar. They may look different, but all of the functionality is here on these tabs. In addition, there is an Alpaca tab, which enables you to configure discovery on, or not to have discovery on at all if you prefer, and to configure some of the Alpaca specific features, such as the image array transfer mechanic. So, as I say, this should be fairly familiar functionally to you if you've already used Conform. So let's go back and select a device and run the test. So I'm going to select filter wheel on there. So we've now selected the Alpaca filter wheel simulator. We can just click on that. It is now selected in the status bar at the top, and we can go back to the home screen ready to test. Now I'm just going to bring up the image of the filter wheel simulator onto the presentation as well, so that we can see that changing as Conform runs through its test. So clicking on the start button now, you can see it's reading a lot of information first off, as it does. It's just got all the filter wheel names, and now it's moving to each filter wheel position in turn, making sure it can get there and that it is stable when it does. And as you can see, the simulator is showing some activity as the test progresses. So at this point, we've now successfully tested the filter wheel simulator. Conform Universal has a couple of additional features that are not in the Windows version of Conform. The first of these is the Alpaca Discovery Map, and what that does is to give you a visual presentation of all of the Alpaca devices that it can discover on your network. In this case, you can see the one Alpaca device with its list of Azcom devices that it's supporting. It provides all of the Azcom device types. The available Azcom devices is a representation of that data, which is ordered by unique ID, which will help if you happen to be running in a multi-homed network environment. It helps you determine what's going on there. The other additional feature is the device setup page, and what this does is provide us with access to the HTTP pages on your Alpaca device. In this case, the simulator, and just go back again to the Conform Universal. We can click the device setup page this time and gives you details about that specific filter wheel. So those are the primary features of the demonstration. So I'm now going to hand back to Bob to open up the live section of our presentation today so that we can take questions from you. Thank you very much. Okay.
Thank you, Peter. Thank you. Thank you. I should point out at the very end of Peter's demo that the buttons he was pushing on Conform U running on one of the Raspberry Pis was bringing the web pages up of the devices, the settings pages for the devices on the other machine. So those setup pages were being served across the network by HTTP and, HTML. Just so you know, stuff's not built into Conform U. Those are the same exact dialogues or setup pages that you would get if you went on to the machine that has the actual device on it and tried to display them, or anywhere else in the network, really, because you're going to get that data back from that endpoint, which is pretty cool. All right, I see Dale Gent. Let me get this one. Correct. And Dale, to answer this is all part of a larger issue that I would like to point to, which is on this page of the Azcom website. Let me make sure everybody sees this. Boom. And that's the scope of application. And Peter probably has some to add to this. In fact, his articulation of our security model in our discussions has been actually probably better than mine. So if I could turn it to you, Peter, to explain why our security model works the way it does, and the basic HTTP access authentication is in there. It's not, well, anyway, I'll take it away.
Okay, thank you, Bob. So security is an absolutely vital element of IT in this day and age. And every week that goes past, it becomes ever more important. This is not an Alpaca specific or Azcom specific. This is simply IT specific issue, and it's cross-cutting for everything. I think Dale makes a good point in he's talking about his question is basically, why don't we introduce more sophisticated security standard into Alpaca? And do we need more sophisticated security? Yes. Should it be in Alpaca? I personally don't think so. And my rationale for that is that I think that there are other ways of achieving that level of security rather than burdening every single Alpaca device with a requirement to become that secure. I recognize that in today's world, zero trust networks are becoming more prevalent. But in achieving that, if you're going to start running in a zero trust environment, you're going to have some really sophisticated IT capabilities in place to support that. And for that reason, I'm very concerned that Alpaca devices will simply become an incredibly complicated protocol, security protocol setup that, by the way, happens to do something for astronomy, as opposed to being primarily an astronomy API with a minimal level of security built in. When security managers are assessing devices, they're not assessing security of an overall site. They're not just going to be looking at devices, they're going to be looking at multiple layers and all the rest of it. And for that reason, I would much rather put the security into devices that are designed for security, into the sophisticated switches that you can get, into the application firewalls, into demilitarized zones, networking zones that you can put in place. And so security officers can will keep on coming up with ever more sophisticated requirements for security. And we do not want to burden every single Alpaca device with the need to implement all of these. We would much rather they are implemented in devices that are designed and suitable for that. At the very least, you can put a web proxy, a reverse proxy in front of devices and make all communications go through that. And then you can have as sophisticated a security access control mechanic as you require, including HTTPS into it and any kind of authentication from basic up through Kerberos up into anything else. So I don't know if that answers your question, Dale.
Well, I have a bit more to add to it, if you don't mind. You probably know that I have a business also, and our business is astronomy software and observatory operating systems, to be more specific. And I see a few of my customers here. And what we've learned by dealing, a good number of our clients are educational institutions with remote observatories, government and other shared access facilities, but really it's the government and education that are the markers here. And what I will say, having talked to them about this, is that they will never approve a device made by somebody in their basement, a focuser made by somebody in their backyard, or a small business, as resistant to tampering and security resistant. They would never, ever trust that. So the general thing is putting security into a focuser or a rotator or whatever to prevent public internet access cracking is a waste of time, because they would never, ever allow that exposure. Instead, the environment they operate in is one of nearly air-gapped, but certainly totally constrained inside the observatory, because the idea of Alpaca, and this is what's important, the real purpose of it while Peter said, yes, you can extend it, you can put your focuser in Africa and your PC or your Mac or whatever in Norway. Yeah, that's not what we designed it for. What we designed it for was to connect instruments, logic together in an observatory to build an observatory system at that level within the observatory, or an extended, physically extended by a VPN or whatever. And that's the design center for it. So there's two reasons. One, the security professionals are never going to trust a focuser from East XYZ company for being totally secure in a zero trust environment. And two, and what Peter said is right, it would just totally burden, and I'm repeating what he's saying. But the point being is that I got feedback from people that you're wasting your time if you're going to try to convince us that your device is strong enough for us to expose outside of what we would put in place otherwise. So why? It just makes it more complicated for everybody and makes it harder for the technology to take hold and grow.
And I would like to add to that from a purely technical standpoint to Dale's question that both ASCOM Remote and the Omni-Simulator support HTTP basic auth. And we actually recommend that other Alpaca devices implement the HTTP basic auth, and the HTTP status codes section of the ASCOM remote document does talk about the return of 400 error codes to report that you are not authenticated to talk to a device. So HTTP basic auth already was a part, and I believe has been a part of Alpaca from the very beginning. And so
yes, it has.
Sorry, it has. I'm
yes,
sorry.
Yes. So HTTP basic
as also is the ability to use HTTPS from ASCOM Remote, for example. If somebody is able to put their device behind an HTTPS connection, then the dynamic clients in ASCOM Remote can use HTTPS today.
But can you imagine installing a server certificate into a focuser? Not right. I mean, maybe not. I don't think so. You're going to have to buy it. It'll cost 3 times what the focuser costs, because it would be a regular website server certificate, right? So, yeah, not really. And I will say this about the access authentication, basic authentication. The place where that would come into play and why it's there is a shared facility where you have not that good of a overview of what people are doing. So you have clients in a shared facility who now could have access to other clients' equipment. I would say you wouldn't want to put that into place, but people might, and they might want to depend on that to prevent client A from reconfiguring client B's devices.
And I know that one thing that I will never do with the Omni-Simulator, I do hope to enable easy HTTPS from the Omni-Simulator for testing purposes. But one thing I will never do is include a certificate to be installed in an end user's computer, because I have no wish to ever be a certificate authority of any way, shape, or form. If someone wishes to use the HTTPS or the more sophisticated authentication that the Omni-Simulator supports, you're required to handle that yourself, because I am never going to be a certificate authority.
Right. Nor will ASCOM. So lesson out of this is it's designed to be used in a constrained, closed environment, not for public internet. It's not IoT, let's put it that way. It couldn't be any more different.
Yeah. So I've just answered another of Dale's questions. Well, I'm afraid I've answered it with a question, but he's saying that yes, but there's no development guidance on any of this. So I've just kind of pushed it back. I guess I'm guessing what he looks for is just a written summary of what we've said.
Yeah, I don't understand his question. No development guidance on.
So this, I think,
HTTPS, is that what he's talking about? Do you think?
Well, I'm hopefully it will clarify it.
Where's Dale? Let me find him. How do I find him?
Get him. Yes. Can I?
I want to bring him in.
Yeah.
There he is. Hey, Dale, you're alive?
Am I unmuted?
No, you're not. Go ahead.
Okay. Okay. I didn't know if you had me muted.
This is good.
So my question stems from I work in the secure storage industry for a living, so it's kind of like network security and storage is kind of like my sphere. The guidance I'm looking for is if you have a Alpaca client that's trying to reach an Alpaca service, right? If that Alpaca service is running HTTPS and with a self-signed cert or something like that that the client doesn't necessarily know about, what will the client do when it encounters this chain of trust? It's undefined. So
right. And you end up having to tell the client that this is a trustworthy certificate. Now you've got all kinds of admin problems.
Yeah. It's up to the end user who wishes to deploy a device with HTTPS. Right. So like what I'm working on for the Omni-Simulator right now is instructions for the end user who wishes to use HTTPS on how to generate their own certificate, have the server load it, and then how to trust it on their different machines. The problem is if ASCOM tries to come up with some way of creating trusted certs for people, we've become a CA.
I'm not asking for that. I know about being a certificate authority. I've helped run one. The aspect I'm looking at is at a protocol level. How are the expectations managed between service and client? If I were to, dive into C++ tonight and use curl to implement a Alpaca client library from the most basic levels, do I even give HTTPS a consideration?
No.
In that code.
Simple.
Should I?
No.
Right. Well, I'm getting mixed messages because Daniel says that you can also do it. So this is the kind of guidance that I'm the kind of clarity that I'm looking for here. And
I guess, sorry, Dave, if I can just jump in here, this is why, I did look at this kind of, I don't have your experience in this. It wasn't my area, although my career was in IT. That's why I was suggesting reverse proxy servers in front of devices, because that enables you to terminate an HTTPS connection. If you want to have your own personal certificate on there, that's absolutely fine. And the reverse proxy can then deal with that connection and the authentication side, and simply, if everything is okay, pass the connection on to the Alpaca device.
Correct.
At the client end, you have got to find a certificate. You've obviously got to install the certificate at the client end, and so.
But the client still has to know.
I want to
provide the
tell you
credentials.
Actually, guys, I'm going to cut this off because this is an endless conversation that most of the people here don't care about HTTPS. They're not going to run HTTPS in their observatory. And this is a corner case, and it's probably better discussed on the developer list, where if you want further guidance, we can provide it. But this conversation could keep going on forever with regards to HTTPS. And I'm sorry, but I just, as a moderator, I think I just need to cut it off. I'm sorry.
Well, I'm going to ask Dale then if he can send me an email setting out what he thinks Alpaca, what he thinks we should be stating in order to meet his requirements. We can then assess that and decide whether that is somewhere a direction that we think is a good one to go in.
Yeah, that's good, because I don't want to bore everybody else here. This would not be something that would occur in 99% of the observatories out there.
Agreed.
So that's the reason I wanted to take it offline. Okay. Han, thank you for attending. I see you're there. Thank you for putting native Alpaca into HN Sky so quickly, and for the Sky Simulator both. Those are two really cool things. So thank you.
Okay.
Agreed.
Han was one of the first people to build native Alpaca into his planetarium program, and was very much appreciated. I'm glad, it was very nice of you to put your trust in us. Thank you. We have one other issue, which is a philosophical one, and I fear that we may get caught in another discussion, that endless discussion. But what I'm going to try to answer Tom in a way, Tom Field, his question, if you scroll up to, well, and there's a long question from Tom to 1:30, well, whatever, 30 minutes into our thing. Oh no, he sent it to me directly. All right. So Tom, let me read your question, or do you mind? Let me put you on here. Where are you? Tom Field.
Sure, go ahead, read it, no problem.
Okay. Trying to picture the process as a developer. He or she wants to talk to a particular device, let's say a ZWO camera. I know they can use the chooser to open that device. Can you discuss for us newbies something about how a developer handles knowing what capabilities the given hardware has? And I'm going to stop it there. And I'm going to give you a partial answer now, but it's a really mostly answer. Each device looks exactly the same. There are a few capabilities that are optional that a device can report. For example, a mount can report whether it can be synced or not. Okay, there's that. But all of those things in that interface are fixed. That makes it a universal interface. That makes it a contractual, what Peter said before about the conform checker, it's a contractual fixed interface. I know where you're coming from, and I don't want to get into a standards war here. That's not our purpose. But where you have to find out what you're talking to first, you don't have a standard driver client interface. Coming in, you don't know what you have. And what Azcom, as in principle, what Azcom gives you is a known set of functions. Every device has that same known set of functions. So you ask yourself, how in the hell did you do that? All these things have wildly different capabilities. Well, if you think about it and you start to look at it and you roll up your sleeves, you find out that fundamentally their function, what they do day to day from one device to the next, isn't that different. I want to stay away from cameras for a minute because I think people will understand this more easily. If you have a mount, what's the most fundamental thing it needs to do? Move the telescope and point exactly to a spot in the sky. Exactly. And then from there, track it perfectly. If you had a mount like that, you wouldn't need any kind of doodads to make it better. The closer you can get to that, the better. So every mount has its own technology to make it as good as it possibly can be. Servo currents, mount encoder ticks, PEC, whatever, pointing models, all that stuff. So all of that is not part of Azcom. Azcom interfaces are designed to support the routine operations. Now let's switch over to cameras. There are modes that the camera can run in, but its fundamental purpose is to acquire images onto a sensor and transfer that image to the machine. So there are differences in how the photons are picked up on the chip, but really, like even the CMOS, they have low gain, high gain, and then they have you can bin, and then there's one-shot color, which returns Bayer matrices. But if you go read the interface, the camera interface, you'll find that the functions of the cameras are covered, but the function calls are all the same for all the cameras. And so to answer your questions, there is no discovery other than to figure out which things are optional. And each interface has a set of potential optional. There you go. Okay. So did that answer your question?
Yeah, that's the first step, but I'm having trouble appreciating that I don't need a camera in hand to actually test my code talking to a camera. I understand you'll handle all the communications and the properties. How do I know whether I did it right as a developer?
According to the spec, and you run it against and you follow the spec, and then you run it against the simulator. If it works, you're done. And I'm not kidding you. All of my testing of my automation software for years has been against those simulators. And I put them out in the field. And when it doesn't work, I always end up finding bugs in the devices, not in my code.
Good.
So
It's nice to know the simulators are as good as you're saying. That's wonderful.
they are. They're really good.
Terrific.
That's the whole point of those simulators is they're reference implementations and they're very carefully tested, and what they do is what we say they should do. And I ran into a problem the other day because I got called out for being wrong on the home function on a mount. And I thought that thing would be asynchronous in the simulator, and it's not. And then you go read the spec and it says it's not async. And I was laughing the whole way after I got off the phone. One of the mount programmers caught us out on that. And I've now put that on our list of things to deal with for asynchronous. But anyway, yes, the simulator really does. So when Daniel says he's got a simulator for that stuff, those are simulators that you can develop against and be confident if it works against the simulator, it's going to work.
Great.
And if it doesn't, it's the problem with the device 99% of the time. And that's what I meant when I said with the universal interface, it makes it easy to find out where the problem is.
And if you do find an issue with the simulator, we can typically fix it pretty quickly, or actually add, with all of those checkboxes for options, a new case that you can run in the simulator. So I want to run against a mount that can't sync. I want to run against a camera that can only do X, Y, or Z. And you can configure the simulator to be in that mode. And now you can test it against very limited hardware all the way up to a full implementation. So there's a lot of flexibility there. Yeah, already right now. But if you do find any problems with the simulator or weird behavior, please reach out to us and we can address that. That applies both to the platform level simulators and the cross-platform Omni-Simulator.
And that is an excellent question you asked, Tom. It really is something that everybody should understand, the difference between a universal interface and one in which you have to discover and then adapt. And you never know what you're going to find when you connect to a new one. And you have to have one of them there. The whole point of it is not to have, is that you as an app developer should not have to have a warehouse full of mounts in order to make sure that you can handle all of those mounts out there. That's shifted over to the mount developers or the camera developers to conform. If they conform, you're there. And that means the one that comes out next week that you didn't have in hand, that you released your software last month, and now somebody comes out with a new camera, and you don't have it, now what? So, oops, well, you've got to, you have to wait 6 minutes after you do this, and then this bit becomes this way. And well, now you've got to change your software. And then, well, now you got to release another version of your software just because somebody else released a new camera. That's the whole purpose of Azcom since 2000 is to eliminate all of that nonsense. And that's not new. That's not some sort of great innovative thing. The layering, the standardized universal interfaces and layering has been around in computing since the late 80s. So it's just new to astronomy, new-ish, I guess, 20 plus years ago. Does that make sense?
It absolutely makes sense. Thanks so much. It's encouraging
Good.
to know that you have handled all this as well as you have.
It's just a bunch of volunteers doing it, and it's a lot of work and a lot of very detailed work. And so, if somebody wants to help, it's getting into the core team is by invitation, which it is in most open source things. You kind of have to get involved and do some things. And then one day somebody goes, hey, you know what? You're doing some good stuff here. Would you like to join our team? And so if somebody wants to do that, again, what we could really use is a Alpaca Python library. I have an answer to give to somebody who's using Flask REST-X, but that's super heavyweight. I have a rotator simulator I wrote with that, and I'm going to send it to him just for him to laugh at because I don't know how to program Python at all. But it passes Conform, so what the hell? Anyway, that's the point of a universal interface, and it's not appreciated the depth and the meaning of that universal interface. And it's by you asking that question gave us a chance to give people a detailed answer. Thank you.
You're welcome.
Right. Let's see what else is out here. I scrolled way up to see that. Okay. It looks like the other questions. James Bennell. Oh, no, that's an answer to James. Let's see.
I think we're up to date with the questions, but
Yes, it looks like it.
If
Okay, well,
anyone's got if anyone feels that isn't the case, can you just drop something in the chat again and point us back up at your question if we haven't answered it?
even a star would do. And then you can keep typing. Okay. We still have 50 people. This is pretty damn good.
Yeah, absolutely.
This is really good. Now, one thing I wanted to bring up, which I just got going really V2 of yesterday, besides the Conform and the simulators that Daniel talked about, I'm going to share my screen again and look for this. Azcom Alpaca developers. I think this is what I wanted to show. Ready, set, share. Can you see that? It looks like my chat may be on top of it. How's this? Does this look like a browser display of Alpaca, not just for Windows anymore and all that? Okay. So to find this page, you go to the Azcom website, go to Alpaca developers here, and you're there. All right. Over on the right, here's how you get Daniel's Omni-Simulator. I'll just go over there right now. And you go down here, and here are all the different builds and the source too, but here's a cross-platform for everything, just about, as you can see. And then to get Peter's Conform Universal, there's this, and you go down here, and it's a pre-release, so you have to know to expand the assets here. I found out that they're not expanded on pre-releases, and they're pre-expanded on releases, that was a piece of GitHub trivia I just found yesterday. But here are all the builds for Conform U. However, if you have a Raspberry Pi around and you want to just put together something quickly, you can go to the Alpaca Workbench, and this will download a package which you can put on your Raspberry Pi and install, and it puts in the berry menu the Conform Universal and the Omni-Simulators, so you can just click right from the berry menu and find them under accessories. And it also gives info on how to install Wireshark. And I'm going to expand this somewhat. How's that? Does that look pretty easy to see? Can everybody see this, what I'm scrolling through?
Yep.
Peter? Yep. Okay. So it comes with this dock, and it shows you, this is what it looks like in the Pi once it's installed. And then it shows you how to put in the simulators, and then it shows you how to test them out, use them, and how to use the simulators from Windows. So it's kind of a workbench for Alpaca if you want to get your hands more dirty, and then the extra stuff you can do on Windows, speaking out to an Alpaca device and using this Open API browser. I call it Swagger still, but I think they really have tried to change the name to Open API now. And then Conform U, and finally, there it shows you how to use that. And finally, how to install Wireshark in a way that will not force you to be root in order to capture packets, and then how to configure it so that you can follow right along with the rest right there, which is really cool. I mean, that's, if you're debugging at the protocol, at the wire level, this is really nice. You can just see the whole process and open it up and dig in. So that's out there also. When you install this, you get this PDF manual with it, and that's this thing right here. So I thought I'd let everybody know about that also. That was just yesterday. Okay. I think, Daniel, do you have any wrap-up comments?
No, I think we've answered pretty much all the questions.
How about you, Rick?
No, I just, I'm overwhelmed by the participation from the community.
It's great.
I have
Rick is-
I want to just clarify my question to Peter there, because what I meant was on the Conform U GitHub download page, there's a version called Conform.NET 64, and there's another one called Conform Windows, and they're both Conform U, I think.
Yeah,
sorry,
sorry.
I don't understand. Yeah.
Right. So the difference are that they're simply publishing differences in .NET 6. The ones that are labeled .NET require .NET framework. .NET Core, .NET 6 support libraries to be pre-installed on the Windows platform. On that Windows platform. The other ones are standalone publications where they're just Xcopy deployment.
Right, perfect. Thank you.
And the Alpaca Workbench, all of that is what Peter said, Xcopy. Basically, you just copy stuff. The entire environment, it's like a virtual environment in Python. The whole thing goes in and you don't have to install .NET on the Pi. So they're self-contained developments. And if somebody wants one of that Workbench for 64-bit, the Omni-Simulator runs on 64, but Conform U I had a problem with. And so I will build a separate 64-bit, and there's a 64-bit Conform U. So that's the way to do that, is just build a separate one.
Can I just, for those people who have been very kind to stay with us, if we were to do another one of these in a few months' time, what topics are there topics that you think you would like us to cover or go into in more depth? What are the sort of things that interest you that you'd like to see in a follow-up video?
And if you don't think of it now, put it onto one of the two ASCOM lists. Also, that's a place to put it. But really right now would be, if you can put it in the chat or something, would be really useful.
Oh, Susan.
Yeah, she's raised her hand.
Well, yeah, that's supposed to be a raised hand, but it's actually a waving hand, but that's okay.
That's
Same
good.
Difference. Was this workshop intended for developers only? Or why I'm asking the question is because I have no expertise in software development. I'm an engineer, but I'm a user. So I was surprised that the conversation seemed to focus on the development aspects as opposed to user aspects. So I was wondering, are you, my first question is, was this intended to be strictly a developer style workshop?
No, it was not. However, it inevitably drifted that way because we're still in a developmental stage of getting Alpaca out there. There's a lot of development work to be done. People are not using it widely. And so the user experiences are coming when you see more equipment out there. I know where Daniel works, Optech, they use it heavily. Simulation curriculum has it built in now to their iOS iPad planetarium app, and Han has it in HN Sky. Patrick Chevali has put it into Carte du Ciel. So it's coming along, but as a user, here's what I would say to people here who are users. If you like what you heard about, if you like the idea of this, if you like the idea of people coming in and developing applications, not having to have a warehouse full of equipment and to test with, and being able to run their applications on cross-platform, then let your vendors know that you're interested in it. Because without user feedback to the manufacturers and vendors, they're not going to do anything. If you just, man, this thing is a pain in the neck, and then you just use it, then they're not going to know. So if you think this is cool, let people know, and it'll help. We don't benefit from it. None of us get any money for any of this. So it's just us trying to make astronomy better. And you can help by telling your vendors that you saw this thing and this is really interesting. Do you know about it? Are you aware of this? Should I be buying another Wi-Fi or MiFi and it only works with this telescope, and or whatever? So, or the drivers, if they aren't working right, don't just change to native and then don't say anything, because then you just defeat the purpose. So anyway.
I'm strictly a user, and I'm a fairly recent user, only in the last couple of years. And it's been strictly because I've been getting a backyard observatory up and running so I can do it remotely from inside the house if I don't want to go outside,
Neat.
And although I've learned how to use the stuff, I'm more, it's been a case of, oh, it works. I don't know why it works, but it works, and I'm happy with it.
That's good.
But I'm strictly like everything is Windows. I'm using Windows PCs, and I thought that by participating today, it would I would learn more about what ASCOM's for, or ASCOM Alpaca's for, and what it's not for. And honestly, I haven't really gotten that much out of it in that respect.
That's good feedback. I can answer the question pretty quickly, but I understand what you're saying, and we did not cover that.
Yeah, and maybe in future workshops would be really beneficial, particularly if they were to focus on the user, and particularly beginner level users. So. But it's still been interesting for me, because eventually I want to learn how to do, I'm starting to teach myself Visual Basic. My experience with software was 45 years ago at university. It was all Fortran 4. So that's the extent of my background.
Gotcha. Well, to answer, I have one other person with a raised hand, Brian Halkett. I'll answer your question the short way. Whoops, are you still talking? I'm sorry. It looked like, did I cut you off, Susan?
Oh, no. I've given you my 2 cents worth for now.
Okay, I'm sorry if I cut you off.
Oh, no.
So is Brian Halkett still here? If so, oh, there you are. Okay. Your question, you had a raised hand. So what was your, but before you do that, Susan, in one sentence, Azcom and Alpaca are to provide connectivity between applications and devices.
Right.
That's what it's for. It's not for you to care about. It would be like the connection from your accelerator pedal to the carburetor in your car. It's just, that's it.
Yeah. Okay.
So, okay, go ahead, Brian.
Yeah, I have a software development background, but primarily approach this from a user point of view. What I do is very similar to what I believe it was Susan was saying, is setting up remote observatories, doing EAA and kind of delving into the evil art of astrophotography. And I don't want to sit there, and I fortunately made that jump pretty quick, where I don't have this huge supply of really expensive eyepieces. I just got to spend money on cameras. So I also don't want to sit outside in the cold. I want to do it from, indoors where it's warm. Now, what I've primarily been doing is using a mini PC, setting up Azcom Remote and Alpaca, and then connecting using the CPWI Azcom drivers to Sky Safari. Okay. And doing that. And what I found is, hey, running that stuff and doing live stacking is pretty intensive on a mini PC. Some people have gotten away with the Celeron, like the J4125s. I wasn't so lucky. I think those are more the astrophotography folks, but I discovered, and this is kind of like the lack of tutorials, the outreach kind of part, which I know developers kind of like right next to writing documentation, doing outreach to end users. But it's kind of this, I mean, what I'm thinking as I go on, hopefully a little bit in a convoluted talk, is that you want the vendors to use this, but what's going to make them do it? And that is well, either one, it's really cool, or two, the buyer of this says, hey, is this Alpaca compatible? Can I use this on my observatory? And they're going to start to demand that. And to that end, I'm really struggling with what can you put where? How do these puzzle pieces fit together? And I basically have a mount with a fairly powerful PC on it that's capable of, I'm running disconnected. I found out during one of the Messier marathons earlier this month, one of the German guys is using Alpaca to actually connect the camera and the mount remotely to a server. So he has a very small mini PC and he's running everything over the network. Now, coming from an application point of view, that scares the heck out of me because I don't trust networks. And I'm assuming you guys are using UDP, so
No.
I want to capture all the frames. And if the network gets a little glitchy, all of a sudden, if I'm remoting into the PC, I don't care. I disconnect and no big deal. It just continues on doing its stuff. So where are these tutorials? Are they available? I want to find out, what should my expectations be on what Alpaca can do for me? Because that was a revelation that people are actually using Alpaca to do that kind of, stuff. I didn't even know it would do that.
Wow.
Or if it's even recommended. And so to that end, to get the vendors to say, I'm going to use this, how do I know what to demand or expect of the vendors based
I
on
got
this
it.
capability?
Peter, you look like you're ready to, you've got an answer on the
Well,
tip
I
of
was.
your
I think
tongue.
that the one thing that you talked about, Brian, was it uses UDP everywhere. No, it doesn't. It does use UDP for the discovery phase on the local segment or the local broadcast segment, but it's TCP over for all of the business level communications.
So if I'm sending subs over and there's a glitch in my network, what actually happens?
You lose.
Well, that's the TCP/IP handles
Right.
that.
Yeah, but it might as well be UDP in that particular instance. It might as well be Netflix, and it just says continue along.
You will
right?
not
the
lose.
point of the TCP/IP protocol is
we're
that
getting-
it guarantees delivery, or it's
Right.
going to throw you a big error.
When you said your network fails, I thought you meant your whole damn network fails. Like
Oh,
somebody-
no, a glitch.
Okay, well then you don't lose. It's TCP has delivery guarantee.
Okay.
This is HTTP. So if you're able to see a web page across that, you're able to get your images. But if your network fails, that's it. You're done.
I mean, I've had
Here's the
RDP
thing.
connections drop.
I do want to say this, and that is, go back to what we said before. This is designed to work inside the observatory, not to work with your focuser in China and your PC in Israel. That's not, it's crazy to run an observatory that way. So
to that end, that is not a recommended.
No.
Okay, because I kind of freaked out.
The
I'm going,
reason for that, Brian, is not just because of unreliable networks. It's because of latency in the network as well, round trip time, not just literal network.
Okay.
And even if you set up and you would have to set up a VPN, or you've got humongous security issues.
Right. Okay.
So,
okay. I was just trying to figure out, boy, I'd never seen anybody do that way. And it kind of made me a little bit like, wow, okay. I don't trust my network enough to give a reliable connection to be able to do that. And
I think you're right to be suspicious of it.
Okay.
But like, for example, at my house, I have a very powerful desktop that I don't really feel like putting out in the cold. And I can use Alpaca to access the camera images coming out from my backyard over a wire in the house and do my data processing on the PC. They're on the same network. Everything's happy, but I don't have to stick my giant 40-pound tower in my backyard right next to the mount.
Okay, so you are effectively connecting to Alpaca across your local area network then?
Yes.
But that's it, local net. And that includes Wi-Fi. And if you want to physically extend it, you can extend it with a VPN. But then you've got the network the VPN rides on is now a weak link or a potential additional link in your system. So if you have observatory,
I wasn't talking about he's controlling it, like he has a server he has in Chile and he VPNs into it from Germany. No, but and then has the local server that he tunnels into the darn thing and does that. No, I was just talking about, I wouldn't do that from my living room down to, my backyard. It just seems like even with
That would be fine.
even with a solid network, it seems,
I think your fears may be not so justified on a local Wi-Fi network with lots of power and in a net, because you have the same situation sitting in your backyard with your laptop working off your Wi-Fi, right? And how many times have you seen your web pages interrupted?
Too many times. I don't know. It's weird. Big house, doesn't go through walls very well.
Well, yeah, if your Wi-Fi is weak, I get it.
And it's an Arrows mesh network running IP6, and I'm not running 5 gigahertz. So the wall shouldn't, so 5 gigahertz, you get clear path, you're going to have the bandwidth. But then again, I pick up my laptop and move to a different room, and it has a problem with a wall. But that's kind of not your guys' problem.
We probably need to move on from this because we're talking about not Alpaca, but your network design, and that's not anything that really a lot of other people want to know. So move on.
Thanks.
You're welcome. Somebody else had something. Who was that? Maybe not. Somebody did. Huh. Maybe they gave up and took off. We still have 44 people, so that's pretty good. Okay.
It seems
Go
to
ahead,
me that we must be about there, Bob.
Yep.
I had a question.
Joe.
Yes. But Susan actually was very similar to my question, that approaching it as from a user perspective. I'm hoping to move away from Windows, and I wanted to see what the options are. It sounds like it's a little early for that. They were still developing the devices that would be connected.
Yeah, from a user point of view, we are making plumbing. And that isn't going to provide you with anything in and of itself. It's just plumbing that can be used by app developers and device developers to connect their things together and deliver capabilities to you. So a mount maker might choose to make a Wi-Fi enabled mount with no wires and is Wi-Fi, and then your machine could have a Wi-Fi adapter and talk to that mount or any other mount that speaks Alpaca. And if you want to move to Linux, now you need to look for the software that you need to do your astronomy that runs on Linux. That's the first place to go. How do you find programs that will do for you what you want to do on Mac OS or Linux? Once you have that, now you start to figure out whether or not those programs will work with the equipment you want. And that's going to be a while before that moves off Windows, because I'm convinced still at this day and age that it's probably, other than the do-it-yourselfers, which there's a heck of a lot of them out there running on very tiny machines with a lot of, put together DIY type stuff. But apart from that community, most of the delivered, supported commercial software or large scale open source software is for astronomy runs on Windows. So there's a few of them that don't. That's right. EKOS, and those things that run on Linux. But I think that's fair to say that the majority of it runs on Windows. So if you find something that you like that runs on whatever other platform you want, good. But I would also say this, which is more important to you, capability or platform? If you had to buy a car that you were going to use to transport your family, would you buy the car that fit your family the best, or would you worry about the brand of car that you have? I mean, it's just why.
I'm worried about the car deciding it's going to upgrade its operating system in the middle of an observing.
That's a huge problem, but that can be managed. But that's a big one I hear, and that's driven a lot of people off Windows, and that's for sure. But it can be managed. It can be forced to be done during the day if you leave it on. So
thank you.
I do believe we are pretty much wrapped up. It's been, close to 2 hours, which was pretty good. Pretty good.
Yeah. Brilliant.
All right, last chance. And Susan, the reason I kept thinking I was stepping on you is your icon there is always talking and it's moving all the time, and I think I'm stepping on you.
My icon or do you mean
Your
my-
thumbnail, your avatar? It's constantly going like this.
Oh,
I think,
really?
wow, man, I stepped on her again.
I can't see that, I guess.
It's animated somehow. It's really strange. I haven't seen that before. Did you?
I'm
Oh, you
unique.
just, yes, indeed. And I hope you can find, everybody here who's not a developer can find software that they want.
I'd love to have Sky Safari on Windows, not just Android.
Oh. Well, it's on iOS too, and on the Mac.
I'm not.
I believe.
I'm a
isn't it?
Windows. I'm a PC.
Okay. Yeah. So pretty much I am too, but I've got other stuff too.
And we
Well,
can end on a high because John, or at least for me, because John Carter's managed to get Conform U running on Apple Mac. And that is an absolute first. So well done, John. Thank you very much indeed.
How about that? There it is.
I believe you did the Omni-Simulator as well from an earlier message.
Say something to us, John. That's pretty good. I asked you to unmute yourself. So click. There you go.
It took me a little while. I had to run Gatekeeper on every DLL that it wanted to run.
Oh my
Yes, I'm
God.
sorry about that. There were about 400, I think, in the distribution.
Well, once I got through the Gatekeeper problem, the apps came up and running, and they look pretty good.
Absolutely brilliant. Thank you very much, John.
You're welcome. And that's the simulator as well.
Well, when you use them, after you finally get your head around the fact that they're serving their UI through a web interface, and that was Daniel's contribution using Blazor, it's brilliant. It just, the whole concept of that is just amazing. Daniel brought Blazor to Peter, and the two of them together have done amazing things. So
Well, what surprises me is that they got DLLs, window DLLs are working on a Mac.
well, they're not Windows DLLs. They're actually .NET assemblies. They end in .dll, but they're not native code. They're actually assemblies. Well, they may be. I don't know. Depending on how they build it, they may have been built native for the Mac. I don't know. Were they boiled down, or are they?
The answer to that is complicated and probably out of scope for this particular.
Yeah.
Suffice to say, it is running on the Mac as a Mac native application.
Yes.
Regardless of what the file extension says it is. The file extension is irrelevant. It was just added by the build tools.
Yes.
There you go.
Yeah.
So now all we got to do is get Nina to run on a Mac.
That's a different problem.
Come on, Dale, you can do it.
They have a user interface. That's where I don't know. Anyway,
Yeah.
that's good input though. Okay. Rick, Peter, Daniel, thank you. We had a good time, I think.
Yeah, thank you, Bob. This has been a really good meeting, and hopefully people have found it informative as well.
Yes, indeed. Okay. Well, I guess I'll, Stevie, you can stop the recording if you wish.
Okay.
And so that you can walk away from your PC for the next hour.